Okay, first thing I want to do is look at the test and see what you all, how everyone approached it. Let's see here. Why is that 2 pages? But then it should go up to, I guess it won't let me. Okay, so our problem was to accept a student's name, major field of study, and grade point average, and display a student's data with the message Dean's List if the student's grade point average is above 3.5, not equal to, but above. Academic probation if the grade point average is below 2.0, and no message if the grade point average is between 2.0 and 3.5 exclusive. This is not a modification of test number 1, so you did not need test number 1 at all. And so you were to use a dual alternative if with a single nested alternative if in the else. So the following is required. You were to do a pseudocode or flowchart, JavaScript, and then zip the file up. Here was the example runs. Now you didn't have to show these to me, but when you did the problem, these are the values that I would test it with, and whatever information you put up here. This one, if it was 3.5 input, you should not have gotten a message. 3.8, you should have gotten Dean's List. 1.9, you should have gotten academic probation. Okay, so that was the test document, and I can look at, we can either do it all together or we can look at somebody's. Where's Aaron Crum? Aaron, okay.
Yeah, I would look at mine.
Okay, don't look at yours. All right. Who thinks they did all right on it? Or even if you didn't, David. Okay, David.
I forgot to put student information, so it's all on one line.
All in one line? Yeah, that's all right. Like David line, you forgot to put line break is what you mean?
Yeah.
That's fun. That's no problem. This one, okay, test.
Plus it just says name. The name.
Now you have, that's the actual test, right? Here's where you zipped it.
Right. Whenever I would try to upload it the first time, it didn't give me the option of my zip folder.
Okay.
So I had to do it again.
Okay.
So one folder has got the information in it that uploaded.
All right. Let's see. Save. Oh, and I need to get rid of my mail jumping around. Okay, so if we look over here at, that's AC. Oh, that's where I was going to do. Here's yours. There's yours. Okay, so let's look at the pseudocode first and see, because a lot of times if you at least get the pseudocode right, then you get credit for the logic, and that's what I'm most concerned about these first couple tests, is getting the logic. So here what he did is he has 3 input values, which is correct, and with pseudocode you would say string name, string major, num, GPA. Some students go ahead and do JavaScript and do var on all of those, which that's correct also. Input, name, major, and GPA. Output, student information, name, major, and GPA. And this is real important that this is up here at the top, because some students were putting it down here at the bottom, and if you do that, then you don't know which message it goes with. Or some had this inside each of their if statements, which, but just not on the actual JavaScript. Okay. So if GPA is greater than 3.5, then output, you've made the Dean's List. Else, if GPA is less than 2.0, then output, you've been placed on academic probation. And this would end this if, I think you've got one extra, yeah, one extra end if.
I was going to try to put a third thing on there, like
no message. Or, yeah, okay. You did. Okay.
I forgot.
So that's the only thing that I see here in the pseudocode. Otherwise, this is straightforward. This is correct. He just has one extra end if. But, or it's probably this one, because this end if is lined up with this if. All right. So anybody have any questions over that? Let's see. I'll make it a little bigger there. 200. You guys that are out the back. Okay. So he got his points for pseudocode. Let's go over to the test 2 HTML. And I don't see any red, so that must mean it's going to run. Let's try it. Please enter your name. Please enter your field of study. Please enter your GPA. Okay, let's try it with, if I do 3.5, it should not print out a message, right? And it did not. That's fine. It did do it all in a line, like you said, but it did what it's supposed to do. It printed student information, DW.
Yeah, what I mean is it didn't print student.
Oh, it didn't. You didn't label them.
Yeah,
that's what you said. Okay.
I did it on the pseudocode, but I forgot to put it.
Okay, so we're going to run it again with 3.8. Oops, not 3.8 there. And let's say science and 3.8. You've made the dean's list. Okay, so the logic is correct, or it would not do that. Okay, and see, I don't know. Just put something in there. 1.9, it should say academic probation, and it does. So here is the way David did. He put var name, var major, var GPA. So there are no constants. Some people try to use a constant with Dean's List, and there is a way to do that, but it's really a lot more difficult. I don't usually use constants in JavaScript unless it's numeric. It's hard to get those literals to work. If you did, that's great. No problem. All right, so here's the prompts. Here's document.writeLine. So this is what he's saying. He should have put student name, colon, and then the variable name. And all it did was print the variables themselves out right there, which that's acceptable for this test. I'm just interested in your logic working. So if GPA is greater than 3.5, and then he had brackets here, document.writeLine, you've made the dean's list. If GPA is less than 2.0, and then I see why you did all those end ifs, because this one, and I found out yesterday, I think one of these will work. I'm not sure without the bracket, but this actually is the closing. See, that's an extra closing, isn't it?
Well, yeah.
Yeah, so you shouldn't need that one. No. Because this one's for this if. I see what you put it for this else, right? Is that what it was for? Because that one.
It was also, I was still trying to put that last thing in. I was running out of
Let me
time
see.
when I
That
decided to
should work like that. If, else, if. Okay, let's see if this will work. Should work without those two brackets. Save. DW. Okay. Yes. So those were extra, and I have put those in before, and that's probably why you all did. But after the else, if you have an if, you don't have to put another bracket there. But uh-oh. Okay. The next one, let's see what we need to do. All right, so here we go. me go to the, so any other questions over this? Anybody want me to look at theirs? Everybody got what the test was supposed to be. Okay, so now I'm going to go to the chapter PowerPoint here. Let's see if I can find it, if I can get it open. And we're going to start on looping. So looping, in order to understand looping, you have to understand a decision, because a loop, that's part of what makes up a loop. So that was why we had to do if then else first. Okay, let me go to CIT project solutions. Okay, there they are. Okay. Oh, that says 3. That's not supposed to be chapter 3. Uh-oh. Where? There it is. I don't know what how that opened too. But here we go. Let me put this full screen. I better make sure. If that's getting. Make sure it's still recording here. Where is that? Oh, where did it stop? No, there it is. Okay, I'm trying to find out, make sure that that's recording. And I can't tell for sure now. It's like not on my screens where I can see it. Well, I hope it is. Okay. Won't have time if I don't get started. So, all right. So this one, object-oriented approach to programming logic. This is looping. Here's what we're going to talk about in this chapter is the loop structure, which is the third of the structures that we said in the very beginning of the semester, that if you could understand those 3 structures, you can answer or solve any problem using those 3 structures. First one was sequence, second was selection, this one is repetition or looping. So, oh boy, I skipped a bunch in once. So we're going to, it's the most complicated of the structures. There's 3 parts to it. There is using a loop control variable, nested loops, avoiding common loop mistakes, using a for loop, and common loop applications. Okay, so here is the loop structure. Looping makes computer programming efficient and useful. It's one set of instructions that can operate on multiple data sets. Loop body is statements within a loop. Then there's the loop structure, which is one of 3 basic structures in structured programming. It starts with a test of a Boolean expression, then executes as long as the Boolean expression is true. It's referred to as repetition, iteration, or a while loop. So the one that we're going to work with is the while loop first. At the end of the chapter, I think there's a section, well, it's actually on page 135, starts into for loop, but we're not going to do that one until next week. So with this, what you have to understand is that the statements that you execute inside the loop is called the loop body. But the selection statement is still an if statement. And you'll see that in this structure, you notice there's a decision box there. And that decision box is what determines how many times or if you're going to repeat the loop. Okay? All right, so here's an example of a while loop. While quantity in inventory remains low, continue to order items and end while. So the end while signals where the loop structure ends. And there again, that's pseudocode. That's not JavaScript on how we end the while loop. The structured loop has one entry and one exit point. The body of the loop can contain any number of statements. So up here in the middle, between where we test the loop, you can have any number of actions in there that you want. Body of the loop can contain any number of statements. So here is an example. Oops. Oh, wait, I passed. Somehow I keep scrolling way down instead of sticking with where I'm at. Okay, so the next one is using a loop control variable. A loop control variable is a value that's tested to determine whether you keep executing the loop or not. Okay, so when's this class? We start at 9:30. Yeah, okay. My other class ends a different time. 3 actions occur. First, you initialize the loop, and then you test the loop. And then after the loop variable is also, you have to increment it in the body of the loop. So there's 3 things that you have to do when you use what's called a loop control variable. And that's those things you have to go back and test if your loop's not working. So you need to control the number of repetitions, because if you don't, then it's an infinite loop and it has no end. Wait a minute. Where was this one? There's ways to control the repetition. Now, the thing about a loop is that it can be 2 kinds of loops. There's a definite loop, which is controlled by a counter that tells you exactly how many times you're going to go through a loop. So if you know that a loop you want to execute 5 times, then you'll use a counter, and when it gets to 5, then you cut off. But then there's also one called an indefinite loop, where you test what's called a sentinel value, or you test a variable to be a specific value. And when it is that value, then you stop the loop, okay? Okay, so here's a definite loop. Using a definite loop with a counter, here's what happens. It executes a predetermined number of times, also called a counted loop or counter-controlled loop. The counter, there's 2 things you have to do with the counter. Before you ever enter the loop, you have to initialize it. What do we mean by initialize?
Count equals 0.
Right, count equals 0. You have to set it to either 0 or 1 or something. So variable usually is initialized to 0. Here's an example. This is figure 4-2, and I know you can't probably see this. So let me see if I can get it any bigger here. There we go. All right, that's a little bit bigger, but it's in your book, figure 4-2, which is on page 120. Need us in this. Okay, so my son's having some issues. Okay, so what we do with a counter-controlled loop is that at the top, we're going to set our variable count, and we're going to initialize it to 0. So then when we enter the decision box here, we're going to test, is count less than 4? Yes, output hello. So if we were actually, and I'm going to go over to a Word document because I'm hoping this is recording. And so instead of writing it up on the board, I'm going to try to do it this way. Okay, so if we were just going through this particular, oh, is it not going to let me get it up? I guess that's not going to work. I'm going to have to do it over on the board. So if we're using the values and we're executing through the flow chart, we would start at the top with count equal to 0. All right, when we first start the loop, it says, is count less than 4? Is count less than 4? Yes. So I'm going to do the yes path, and I'm going to output hello. Then it says increment counter by 1, count by 1. So I'm going to add 1 to count. It's now 1. So now I go back up. Is count less than 4? Yes. So I'm going to go my yes path again. I'm going to output hello again to the screen. Increment count again to 2. And then I'm going to go up to the top again. Is count less than 4? Yes. So I'm going to go through again. Increment count. Is count less than 4? Yes. So I'm doing it a predetermined number of times. But now when I enter my loop, is count less than 4? No. So I drop out. My output is goodbye. And then I stop. Right? Okay, so that is what's called a counter-controlled loop. It's a predetermined number of times that I'm going to go through the loop. So that's one kind of loop. Now, I have 2 ways of changing the loop. I can do it by changing the control variable. I can increment, which is what I did in that flow chart, which adds to the variable, or I can decrement, which reduces the variable, or subtract 1 from it. So I could have initialized count to 4 and said count equals count minus 1 each time, and changed the way my decision was made. Okay? So an indefinite loop is the loop execution time is based on the user's input. The loop may be performed different number of times each time the program runs. In other words, I'm going to ask the user to input a value, and it's going to keep asking them to input a value until a certain value is entered. So enter, okay. Priming input. First input that sets the loop control variable's first value. Then there's a sentinel value, which is the value that signals a stop to a loop. Okay, so figure 4-8 on the following slide illustrates an indefinite loop. So here's the indefinite loop. String should continue. Do you want to continue? Yes or no? Input should continue. Should continue equals Y. Yes. Output hello. Output, do you want to continue? Yes or no? Input should continue, and output goodbye. So the difference in this one and what we just did is how many times are we going through the loop? Until somebody says in or no, right? So it's going to, it can print out hello 1 time, and then the user, it asks again. But you notice the priming input is here before you ever enter the loop. You ask the user, should continue, yes or no?
Then you enter the loop, test it. If they say yes, you go here, but you have to ask again before you exit the loop, or you would just be going around and around, right? So there's 3 parts. We have to initialize it or prime it, test it, and then we have to be sure that we alter the loop control variable.
Okay, any questions anybody has about that? All right. There are nested loops, just like we had nested if then else's. A loop can be inside of another loop. There's an outer loop, a loop that contains the other loop or inner loop, and then it's used when 2 or more variable values repeat to produce every combination of values. So it's just like when we had a nested if. We could have a nested if inside an if or inside an else. So we can have loops inside those if statements. We can have a loop inside of a loop. So here's an example. Let me make this down a little bit so we can see the whole thing. If we wanted to print out this quiz sheet, we can see that inside part 1, each time it needs a loop that's a predetermined loop of 3, right? And then the outer loop is a predetermined loop of 5 because there's 5 parts, right? Okay. Tell me if you don't get it, because this is a little tougher right here. Okay, so what this is figure 4-5, which is over on page 125. So we want to create this quiz sheet. So I'm going to make this a little bigger again so we can see the flow chart. Or we can do it from the pseudocode too. Ooh, I do. Yeah, that should be it right there. Okay, so on our pseudocode here, we want to create that quiz sheet. So here's what we've got to have is 2 loops. So first we're going to have declarations up here. We're going to have a part counter, which is going to be how many predetermined times is that part counter going to need to go through a loop? 5. And then we have a question counter because it needs to be set different than the part counter. And so then we have 2 constants. Parts equal to 5 and questions equal 3. Okay, and then I'm not going to write these up here, but then we have part label is a constant, and they're calling it part line, and it's the dot and the dash. So in the quiz, there was a dot line, and that's why they did it that way. Right here we need, if we use the counter for the numbers, and then we use the labels here. Okay, so first thing we do, output quiz, because at the top of my quiz sheet, I want it to say quiz, right? So I'm going to put quiz. And then it says initialize part counter equal to 1. So right now, part counter is going to be 1. Then I do a comparison. So this is going to be my outer loop, right? This one under here is my inner loop. Or I can use this up here. While part counter is less than or equal to parts. So is part counter less than or equal to parts?
Yes.
Yes. So I'm going to go over here. Hopefully the rest of you are understanding too. David's being very good to respond. So you all need to tell me if you don't understand. Okay, so we're doing parts. I'll move it over a little bit. Okay, so part counter is less than or equal to parts because parts is 5, right? So part counter is 1. That's yes. So it says output part label. So what was part label? Part, right? So we would type, it would output part and then part counter, which is 1, like that. Right? See where they got that from? Output part label is part, and the value count right now is 1. Then it says initialize question counter. So we're starting the inner loop. So on the inner loop, we need to initialize. On the inner loop, we need to initialize the question counter, right? Question counter is now equal to 1. So is question counter less than or equal to questions? Yes. Okay. So we are going to take the yes side, and it says output question counter, which would be 1, and then output line, which if we look at the pseudocode, line is the dot like that, right?
Yeah.
Okay. Then question counter has to be incremented. So I'm going to add 1 to question counter. And then I'm going to go down, back up. Is question counter still less than or equal to questions?
Yes.
Yes. So again, I'll output question counter, which is 2, and then dot line. And then I'll increment again. Is it less than or equal to questions? Yes. So I'll go and output again. And then I'll increment, and that'll be 4. Now is it less than or equal to questions? No. So I'm going to fall out, and you'll notice in my outer loop, I'm incrementing part counter to 2. So I come back up and around, oops, this one that goes all the way around here, and I ask, is part counter less than or equal to parts? It's 2 now, is it? Yes. So I'm going to output part 2. And then I'm going to go through that loop again. Does everybody follow? Do we need to go through some more? That's the best way to follow logic through with a loop and make sure that it does what you think that it's doing, okay? Okay, so avoiding common loop mistakes. There are 4 common mistakes. Neglecting to initialize the loop control variable, neglecting to alter the loop control variable, using the wrong comparison with the loop control variable, and including statements inside the loop that belong outside the loop. Okay? Yeah, easy to do, right. So those are the 4 common mistakes that you go back and look at if you have an error in your problem. Okay, the loop control variable, always a mistake. This is neglecting to initialize. Is always a mistake. Uninitialized variables may contain unknown values in some programming languages. Program logic errors will occur. There's on figure 4-7 shows the correct logic for a greeting program. Slide 4-8 shows an example of a program where the loop control variable is not initialized. So these are in your book on
Page 127.
yeah, 128. Okay, so this is the correct one where it's initialized. And this is the incorrect one where they're missing the loop control variable right here and up here in the pseudocode. So in the beginning, this particular greeting program,
they're saying set quit equal to ZZZ. And so what they're looking for is when the user enters the word quit, then they will stop the program. Okay. So if they don't enter anything here, then it's going to stay at that until they go down here. And then they ask again. Okay, so neglecting to alter the loop control variable. So there's two things that are important with the loop control variable. You have to initialize it at the beginning, and then you have to be sure that you put it in the part of the loop where you increment it or alter it in some way to change it, or it'll stay in an infinite loop. So there's incorrect logic where they just output hello, but they didn't give the user a chance to quit the program. So it will be printing hello indefinitely, right? Using the wrong comparison. Sometimes you might use a comparison that the operand is like here, it's greater than quit instead of not equal to. That's what they mean in the pseudocode here. When they do less than and greater than together, they're saying not equal to. Okay. Including statements inside the loop that belong outside the loop, and that's something where if you're doing a calculation that you don't really need for each iteration of the loop, you can put that calculation outside the loop. Including statements inside the loop that belong, oh, that's what we just did. Okay, here's one of the examples of that. This is a problem where it's an, let me see where this is, if it gives the problem. It's on, okay. Suppose that you write a program, it's on 131, states the problem. Suppose that you write a program for a store manager who wants to discount every item he sells by 30%. The manager wants 100 new price label stickers for each item. The user enters a price, the new discounted price is calculated, 100 stickers are printed, and the next price is entered. Figure 4-11 shows a program that performs the job inefficiently because the same value, new price, is calculated 100 separate times for each price that is entered. Okay, so over here, what they're doing, it shows the same program in 4-12, but it's done the right way. But here, what they're doing is new price equals price minus price times discount. That calculation doesn't need to be inside the loop. It can be, or it needs to be at the top of the outer loop, not inside the sticker count loop. Okay? And that's what they show you. Okay, what I want to do now, instead of going into for loop, now y'all remember that I won't be here on Tuesday next week. You can still come and work on your problems together, or you can work at home, however you want to do it. But I won't be here on Tuesday. I will be here on Thursday for this class. And so we will continue in this chapter. But in D2L, in the Evernote, this is the content. I have given you all the assignment, and it says this week, but it's actually what you'll be doing next week, so I'll change it to week 8. But at the bottom here, I give you some Khan Academy that are looping, and then next week on Thursday, I will work problems 3 through 6 in class. But your assignment, that'll be due the day I get back, is problems 1 and 2, pseudocoder flowchart. And so let's go over and look at some examples of looping. You'll notice that I don't have you do JavaScript on these yet. So I have you do one is just one where you're going, it's on page 152. It's where you output by each of the pseudocode segments. So you're going to do A, B, C, D, E, and F. Those should just be in a Word document, okay? That's where you're doing what I was doing on the board. You're desk checking them, okay, with values. Because it tells you, like for A, if A is equal to 3, B is equal to 4, and C is equal to 10, use those values to go through this while loop, and what would your output be for A, B, and C? Okay, so you're going to do what I did over there on the board for each one of those. All right, and then number two is to design the logic for a program that outputs every number from 0 through 8. Okay, so I have some examples here for chapter 4. Let's see, that's not them. Where did I put them? I think they're still over here. Chapter 4. Oh, I thought I had some that say. Here they are. Okay, like here's just a simple counter-controlled loop. Let me see. I hope this isn't one of the problems, but it doesn't matter if it is. This one is in JavaScript. Yeah, it's pretty appropriate. It's Happy Halloween. Okay, what this problem will do, it's going to use the variable constant 10. It's going to use a counter, and it's going to print Happy Halloween out 10 times. Okay, so this is the JavaScript, and I'll put this over in Evernote also for you to look at, although you're not required to do the JavaScript yet. But you'll notice this part, the syntax is similar to an if statement. All we do is say while counter is less than max, and then we use our curly brackets, and our end while is a closing curly bracket. So all it's going to say is document.writeLine text plus a break, and then increment counter. So my initialize is actually up here. I could have just stated the declaration here and then said counter equals 0 here. Either way that makes more sense to you will work. So now if I go up here, preview in Google Chrome, there's Happy Halloween. Should be 10 times. 10 times. Okay, so that is the JavaScript then for like our hello program. It's basically the same thing. Now, if I didn't want to use a variable text, I could just say document.writeLine Happy Halloween here, right? So I just did it with a variable there. Constant, yes. Should be in all caps, and it's not. Okay. Yeah, that should actually be. Yeah, let's put a constant xt, and then I'll have to change it here. Xt. Okay, so now I'm going to save it like that. Okay, so let's look at another one that I have over here. Here's a counter control. Let's see what this one is. This one. Oh, is that one different? There's the output, but oh, is it decrementing? What is it doing? It doesn't have anything in there, so it's going to be a, oh, this is one that I've played with. What's going to happen with this one? It's going to go on forever because there's no increment or decrement here. Because we used min instead of max, it should actually say counter equals counter. Oops, I'm in all caps too, and that's not going to work. Counter equals counter minus 1 for this one to work. And there it is. Okay, let's look at, here's a flag controlled. So this is a sentinel controlled one here. So it's got a little more to it. Let's see. Oh, this has a lot more to it. This is probably a little more than you want to see right now. This one is checking done. If it's false, then it will drop out. And you notice that in JavaScript, to do not, it's an exclamation point. It says, while not done, do this, is what it's telling you there. If response, okay, let me see what this, does this have the output? Overall profit or loss. Yeah, this one has a little more to it. But if we took, let's take this one. Let's change this to, instead of counter, we'll say variable done. Oops, make that a variable done equals okay, so I don't need this. But now I'd say while not done, document dot write line, and I don't need a counter, but I do need to ask the user, right? So I need to say done equals prompt please enter true to, or I could just say please enter quit to quit. Oh, I sure did. That doesn't look right, does it? Okay, let's see if we can make this work. All right, so here goes. It didn't work. Okay, let's see what's wrong with it. Done equals, it doesn't like something here. Equals false. While not done. Maybe I did something different. Let's see. Done equals false. Oh, they made it not a string. That's why. It has to be prompt inner one if you have to. Oh, it won't test. I know why. Because this is a comparison and it won't do that on a literal. So I have to actually go here and make this say done equals false while not done. Prompt, please enter. It'll have to be a probably, that might work. It equals false. Let's see if it's going to go over and over. Please enter quit to quit. But I can enter.
You can pretty much enter anything you want.
No, because it's testing it for, is it going to make done equal to whatever I put in there? So anything will make it quit, I think. Let's see. Yeah, because what I said, what I said is put anything that I put in here into done so it's no longer false. So here I'd say while done is not equal done, please enter false to continue. And I'll just say quit to quit. Let's see what that, to continue or, okay, so let's see if this works. So now if I go up here, preview in Google Chrome, please enter false to continue. No, it still didn't work. So it's not going to continue. It's only going to print it once in my comparison. I'll have to go back to, that's,
To the minimum or some sort of counter.
see, oh, right here says if, okay, here he's just using that to initialize it, but response equals 1 times prompt enter 1 if you have data, otherwise enter 0. If response is not equal to 1, done equals true, compute equals false. While not done, yeah, that one's got too much, that's too involved right now. We'll go back. I need to look at an easier flag control loop. I don't know why that's the only one I have in my group. Well, right now, the only ones that you have to be interested in is number 2. You can do number 2. That's a counter controlled loop, right? So is number 3. Design the logic for a program that outputs every number from 0 through 8 along with its square and cube. So if you can do 2, you can do 3. Because they're just in the same loop. There's just 2 more statements in that loop, right? So if I go over and let's just take this one that I started with, say file, save as. This one is number 3. I don't think I had that one over there, did I? Well, let me look at this one, sentinel averaging loop. No, I'm not going to do that. Okay, file, save as, and this one's going to be called chapter 3, number 3. All right, so if I change this one, I want my counter, my max to be 8, right? Because it says do it 8 times. And I don't need this line. So while counter is less than max, what do I want to do? What does my loop need to do? It says to output every number from 0 through 8 along with its square and cube. So I would output counter, right? And then I could do a break. Oh, plus, I think I have to say plus. ER. And then I want to output the square and the cube. So that means I'm going to have some more variables up here, right? Variables, square. Oops. oops, r cube equals 0. Okay, so I'm going to come down here and I'm going to say, so now document, actually I'll just say square equals counter times counter, right? And cube equals equals square. It could be square times counter, right? Because it'd be,
Counter times counter.
yeah, because if I did square, yeah, equals counter times counter. There's another way to do that, but we'll do it this way. Counter. Okay, so now when I do document.WriteLine, I would say document.WriteLine, and that would be square comma cube. Oh, I probably want to do a break in there. Plus BR plus cube. Okay, work. Okay, let's see what happens. I was kind of on the fly. Save changes. 0, 0, 0, 1, 1, 1, 2, 4, 8, 3, 9, 27. Is it right? 64, I think it is. 216. Yeah, it's just that I didn't put anything beside it. Because the first time through, okay, the first time through, document.WriteLine, it's 0. So square and cube are both going to be 0, right? Then, oh, I didn't write cube, did I? Yeah, I did. Okay. So this is all in one document.WriteLine, so that's why it's kind of confusing. But you can go and fix that, work on it. But you get the idea of what we're doing with the loop. You see how the loop works. All right, I'm going to put, let me go to Evernote and put down at the bottom those examples. Okay, which would be okay, those are the two we went through, and then we just did chapter 3. If you want to play around with that one, you can. All right. So next week, you can either come in class and work on that first assignment, or if you want to do it on your own, that's fine. And I will see you all on Thursday, and we'll do problems 3 through 6. And I will be checking emails and try to get y'all's grades all caught up. So. See if I can go back here and get that to end. It did stop sometime, so it didn't get all that stuff we did, I don't think. I'll do problems 3 through 6, and I will be checking emails and try to get y'all's grades all that's the end, up, didn't it? But it stayed at that same screen, I think. Huh, that's not good. Let me see if it stops. Oh, no. Okay, where is it at that I can take it off? Oh, there it is.